Before we jump ahead and talk about complex statistical strategies to overcome issues of having non-random assignment to achieve better causal inferences, we need to first just talk about what is causality. And at least from the research subfields that I'm coming from in the social sciences, we typically want to make a causal claim about some predictor X and how that impacts variation in an outcome Y. What does this exactly mean, though? So I want to walk through some specific formal notation that I'm going to use throughout the semester, and we're going to talk about this in the context of conducting and designing an experiment. The reason for this will become clear in a second, but one of the key aspects of using experiments is the fact that we have random assignment of a treatment, and this allows for us to achieve better causal inferences. And again, we'll walk through why that exactly is. So before we move on, I want to briefly discuss the notation that we're going to be using to outline a potential outcomes framework. And this will make sense in a little bit when I actually talk about the outcome. But for right now, you can imagine that there may be some categorical treatment that a given person is meant to receive. And rather than using a medical example, we could also think of a context in which there may be an organization that wants to get out the vote and they want to see what messaging strategies work best. And so an individual could either receive a canvasser to their door, that could be 1, and if they don't, that could be 0. You could also have the treatment be the content. So it could be one type of political message is the first category and another type of political message would be the second category. The important thing here is that we're indexing this variable t by individual I. So when we look at the outcome category, which is represented by Y, we have the same kind of indexing here where we have a potential outcome given that someone receives the treatment. And we also have a representation for the potential outcome if that ith individual is given the control. The important thing to remember here is obviously one of these is observed, the other one is going to be a counterfactual, right? The issue that we have is that we don't necessarily know what would have been observed if someone was given the other treatment, right? So this is the main obstacle that we have to overcome with regard to determining what the overall average treatment effect is. And that's kind of why that's the approach that we take, is because it's almost impossible for us to know what the counterfactual outcome would be for someone if they received a different treatment. To kind of restate what I mean by this is that when we think of what we want when we're estimating a causal effect is ideally we want to know what that counterfactual would be, right? Like we want to know if I'm given medicine 1 versus medicine 2, what is the change in my blood pressure? Now, we can also think of that in an example with regard to political TV ads, and we might want to say individuals who watch this TV ad are going to be more likely to vote for President Biden than if they didn't. But like I said, this is not what we can actually measure in reality. So we're going to have to adjust the way that we think about this, right? We're going to have to think about what's the average treatment effect of the treatment among those individuals who took the treatment versus those who didn't. So in reality, what we're doing is we're looking at the difference in means between the two groups as our estimate of the average treatment effect. Each group is going to then act as a counterfactual for the other. So going back to that political TV ad example, what we really can say is that individuals who watched this ad were more likely to vote for President Biden on average than those individuals who didn't. Now, notice that this is very subtle language, but it has both a difference for how we set up our estimation strategy as well as the potential inferences that we can make from those models. Now, I know this is a little bit frustrating, but this is essentially the fundamental problem of causal inference, is that at most, we're only going to be able to observe one outcome for one individual at a time. And so that's why we're talking about this in terms of a potential outcomes, right? We're talking about what someone potentially could do if they were to receive the treatment or the placebo, right? This is going to require some fancy footwork with regard to the way that we estimate that causal relationship, right? There are going to be certain research designs that can only approximate the potential outcomes. And by that, I think I can use an example that kind of explains this more clearly. With regard to the canvassers, right? You may have the intention of knocking on someone's door and talking to them, but they may not be there to answer the door, or they may not want to engage with you, right? There's a certain amount of compliance that is necessary in order for an individual to receive the treatment. And so, in that sense, we actually use what's called an intent to treat as our potential framework, basically being the group of people who just received a canvasser, regardless of whether or not they actually opened the door, is one group. And then the other group is just an entirely different group that didn't receive any canvasser whatsoever. Another fundamental technique, or I guess element, that is built into this causal framework from an experimental design perspective is randomization, right? We need to have the application of the treatment not be a choice that's determined by people, right? If it's something that they can seek out, then what's really important is that seeking out behavior, not the actual taking of the treatment behavior, which really confuses things. So randomizing the treatments such that individuals, or such that we can limit the ability of individuals to comply with the treatment, is essential. If we can do those two things, then we can reduce the amount of statistical adjustment that we're going to end up needing to conduct in the end if our goal is to actually make some sort of causal inference.